Hello everybody and welcome back. This is the third part of this restoration attempt of the HP8672A signal generator. In the previous videos I have repaired the main board. I have straightened these metal parts, and I right to the point that I can start to test, so things are starting to be interesting from this point ahead. This is the main transformer schematic. This is a very strange and odd system that I don't like actually. Basically, the main transformer is always connected to the power line. There is no switch. The switch control only the fan and digital stage, but the main power supply as well as the regulators are always switched on for what I have, as far as I know. It seems to work like that. So what I want to do now is to check the AC voltage coming out from the transformer. I have already checked the continuity of the primary side of the transformer and seems to be fine. I also have checked the continuity of the secondary side and they are fine too. Since the output of the transformer, all the output go to the rectifier board. Sorry, it's out on the camera, right? It's going directly to the rectifier board that is right here. It will not power anything, so I will simply apply AC to the primary, and hopefully the crappy RIFA capacitor will not explode. And I will check all the output voltages, AC voltage on the transformer. Then we will give a quick check on the rectifier board and check with the multimeter, the diodes and the transistors. There is an OCR for over voltage protection. So there are several semiconductors to be checked in diode mode, and see if there is anything obvious. So let's get started with connecting this beast for the first time, at least in the last 20 years has not been powered on. So it will be some fun to try to bring back to life. So this is the first time that I'm applying voltage to the instrument together with you. I will crank up a bit the variac. It's already plugged in, and so I'm at about 50 volts. So let's go and check the output voltages on the secondary sides of the transformer. Remember that this instrument is set at 220 volts. So since I'm at 50 volt, I should be about 1/3 of the expected voltage. Let's see. So between pin 1 and 2, I should have 16 volt. So perhaps I will have 4 volts. Let's see. AC volts. Okay. Yeah, 3.5. That should be okay. So between 2 and 3, I should have 3 and 4, I should have 26. So it's about let's say 7 or maybe 6. Yeah, 5.8. It's okay. So then we have between pin 5 and 6 will be 20 volts, so it's about 5 volts, and the center tappet is at pin 7 and 8, so I should have between these about 5 volts, and 2.5 here and 2.5 there, almost. That's okay. So the next one, we have 9 volts, 0.8, so let's say 10, so it should be 40 volts, is it correct? Yeah, 9 and 10, 44 volts RMS. So, spot on, seems okay. Okay, so I will go up to the full voltage and see the behavior of the capacitors. The crappy Rifa capacitors, under 30, under 50, under 80, no smoke so far. Oh, look at that. We have an LED that is lighting up. First life sign. That's very nice. Yeah, I mean, the track will be very long before to see anything that this instrument should do. But, you know, it's the first sign, the first life sign. It's always a good thing. 210, 220. So let's check again the voltages. Let me zoom out. So here we should have 44 volts. Yeah, of course, it's without loads, but it's 48. Here we should have 20. Actually, yes, this is the center tapper, so it's 22. And it should be 20 volts. That's okay. It's without load. Here we have 29 volts and should be 26. Oops! As expected, Rifa capacitors give it the life signs. Okay, let me open the window and clean the room. And this is the culprit. Look at that. Those crappy capacitors always do this. That's okay. No, not too bad. Actually, it doesn't make any bad damage on the side here. It's clean, nothing. So it's okay. So go back to the test. I just have clipped the terminal and I will install a new capacitor, X-type capacitor later. Okay, I am back to the operative condition, and hopefully it does not damage the fuse. So let's test. Let me move a bit. The first secondary, which should be well, actually I'm not having nothing right. Oh, sorry, it's my fault. So 17 volt and should be 16. Yeah, very good. 29 and should be 26. That's okay. 22.8 and should be 20. And that should be 44, as in, and it is 47.8. That's okay. So the transformer is okay. So we can go ahead with the check of the rectifier board. So while I'm checking the rectifier board, I'm leaving connected to the main supply, because I want to leave the input filter right in the plug socket, which also contain two capacitors that they may cause the same explosion than the other one before. So now what I want to do is to check in diode mode each of these diodes that, okay, 0.52 volts. Okay, so I will go ahead and check each one. The board appeared to be okay, so I give it just a quick clean and it looks good to me. So I will plug in the instrument and see if we have some DC volts. And this is the setup. I am monitoring the 4 output DC voltage from the rectifier stage. 1, 2, 3, 4. C1 through C4. So let's get right to it and start to crank up. I still have to plug to the variac. Okay, so yeah, it's rising up. While I was cranking up the voltage, I have seen that I forgot to monitor the plus 22 volts regulator. So I have added another multimeter, which is right over there, and it's reading 19.5. Well, it's bouncing a bit, perhaps because we still are at low voltage. We are at 120 AC volts in the input. So I will go ahead with the rising of the voltage and see the behavior. Well, it's almost 1 hour that is running at 180 volts AC, and I can't go over since the circuit, the overvoltage protection circuit will shut down the fuse, will blow the fuse, because there is no load here and the voltage here is rising. So this SCR is reaching the switching on point, so it will short circuit the output of the rectifier here, blowing the main fuse. So I left the voltage at 180 volt and it's working pretty fine. All the voltage are within specs, including the 22 volts that is running at 21.9, and I have loaded with a 270 ohms resistor, which is behind there, over there. So I have loaded a bit because I don't like to leave a regulator without any load. Sometimes can be too dangerous, can be fault, can cause damage on the regulator itself. So I think that's it's enough for this video. I will clean the bench from this setup. I will prepare for the regulator birds care. So in the next video I will go for the positive and negative regulator birds, which are right behind here. So must be cleaned and inspected, checked components. So thank you for watching and see you soon.